Good evening, guys. This is Hayes bringing you another Minecraft tutorial. Today I'll be doing a simple demonstration of basic redstone circuitry. I'll show you in the Redstone Electronics Gallery. And first we have the three main redstone components. They're manufactured from redstone dust and various other constructs. In the case of the redstone torch, actually, it's a redstone over a stick. And you actually make those in a 1-to-1 ratio, unlike wooden torches. They're notoriously poor for lighting. They actually only throw off light 7, which is the minimum light at which, maximum light at which enemies will spawn. But they're very, very useful for these circuits. And their primary function, at the beginning at least, is as a power source. Much like you can have a button that will turn on power, a switch that will toggle it, or a pressure plate, you have a redstone torch that is able to provide it. And it'll always be on, unless it's receiving a current in and of itself, but I'll get to that later. The next piece is the redstone repeater, and this actually involves a much more complicated recipe. But what this enables you to do is, essentially, it allows you to control currents that will go in only one direction if you're building very complicated redstone circuitry. It's especially useful for getting things through tight spaces because, as it works actually, it only takes power from the space immediately behind it and only outputs it to the space immediately before it. So this is an incredibly useful piece. It's also useful as a delay timer. I don't know if you've noticed this, but you can actually set it through various different notches. And what these actually represent are different time amounts that the signal is going to be delayed by. And here we have redstone itself. This is just redstone powder, laying it on the floor. This is what it yields. Oh, can't put there. That's where sign is. Yes, that means redstone does indeed occupy the entire space that it sits on. You can't put it in the same space as these signs. So here we have redstone in action. This will demonstrate some of the basic functionality. This lever here can be a power source. Toggles between on and off each time you hit it. And this leads down, this powers this entire block here. It powers the block below it. And thusly, having this redstone wire right next to it, it's able to conduct the current. And conducts the current down here. That goes into the very back of this diode, and that projects it into this iron block here. And this is actually the other very, very interesting function of redstone torches that actually enables them to be so useful for making these circuits. And that's the fact that when they have a current applied to them, a redstone current, they actually turn off. And in order to have the current applied to them, it has to be going into a box that they're like sitting on or connected to in some way. You notice this this redstone torch is actually hanging off the side. So this block is powered. This one occupies the block next to it, and because it has power, it turns off. And when we go over to the lever and we hit it again, it turns the power off in the circuit, and now this light is on. And it's conducting power into this. This is another form of the same function as this. It's called a NOT gate or an inverter. And it's anything that when it's receiving a current, outputs no current, and when it's not receiving a current, it does output a current. So this is one type. It has the torch on the side, and this is another actually. It has the torch sitting on top. And because we have two NOT gates effectively, it means that the state of that light right over there will always match the state of the torch, or the state of the lever. Say, when it's on, that'll be on. Because the NOT gates cancel each other out. It's like a not double negatives, you know? And here's a demonstration, actually, of how to use redstone wiring to go upward a little bit. This is a very, very effective method. It allows you to make a one-wide column to conduct charge upward. This is stacked redstone torches. You can see a block sitting there. This is directly below it, and then the redstone torch that's sitting on top is actually, it's not powered because it's receiving a signal through this. You'll notice if I take this away, it's on again because it's not receiving power, but I put it back, and it's off. Similarly, it conducts redstone current upward into wires. So because these are receiving a current, they're on. So these are very useful mechanisms for building large, intricate circuitry. Up here, I'll be demonstrating some of the finer details of redstone repeaters. I'll be showing you a little bit about the timing. The idea is that each one of these notches represents the delay being increased by 1 tick. And what a tick is it's roughly 1/10 of a second. So I'm going to show you that these, it's very difficult to notice. You usually see it when you have several repeaters after each other, but you can notice it even at this level. This one will delay the signal by 0.1 seconds. This one will delay it by 0.2, 0.3, and 0.4. So they have 1, 2, 3, and 4 value respectively. When I flip this lever, it'll provide power to these blocks, and these lights will go off in order that they receive power. See? And we'll actually notice that these will also retain power. Similarly, it'll remain powered as long as its repeat time is set to after the circuit gets turned off. See? It goes right down the line. So I hope this has been helpful for you guys. It's just a very basic redstone introduction. I'll be doing another cast later tonight on how to conduct redstone charge downward efficiently, because I know it's quite a challenge in this game engine. Alright, so check out my other casts. I will see you guys later tonight. Haze out.